Okay, so if we're going to solve this inequality, the question asks us to use roots and test points to solve. So the roots would be, let's try and find out where the x-intercepts are on this quadratic. So a good idea to maybe, let's move this over. So we have 0, and then we have, actually, no, forget that. I'm gonna move everything else the other way. I want to keep this positive. So minus 11x minus 35. And that's going to be greater than 0, right? I'm just moving things over. With inequalities, if you multiply by a negative, you have to flip the sign, remember? That sign flips if you multiply by a negative or divide by a negative. So as long as you just move terms over straight, you can leave the inequality sign. So this sort of graph is above 0 in what value, for what values of x? That's what we're asking for. So the roots would be, could we factor this maybe and find out where the zeros are here, or where the x-intercepts are? So let's try this first, because when we have a trinomial, it's a good idea to try to factor by intuition there into two binomials if we can. So I don't know, let's just try 3x and 2x to multiply to 6x squared. And then the first numbers that jump out to me for 35 are 7 and 5. So what if we just did this? What if we did 7 and 5 here? This is 21 and this is 10. Oh, whoa. 21 and 10. That can combine to get me 11, right? 21 minus 10. So a few tips. I didn't know this ahead of time. My strategy is, first of all, check the factors that are closest to one another. And for both of these, that's what I did, and it turned out it just worked. So this is going to be minus 21 plus 10, right, to give us negative 11. And just to double check, so this is 6x squared, this is minus 21 plus 10x is minus 11, and then negative 35. Good. Okay, so the zeros are x equals negative 5 over 3. Very good. That's the x value that makes this factor 0. The x value that makes this factor over here 0 is going to be positive, opposite always, 7 over 2. Okay, so negative 5 over 3, opposite sign, this number over this number, and so on. So these are the roots. Now, I'm just going to draw this quickly on a number line. And here's negative 5 over 3, and here's positive 7 over 2. So you'll recall that there are 3 sections on the number line. So there's section number 1, section number 2, and section number 3. With a parabola, the parabola is either going to open upward or downward. It's going to, so the parabola is going to come like this, or it's going to go this way. Now there is some, I would say there's some level of controversy here, because as Gloria mentioned the other day, if I write the expression on this side, this 6 is positive. But if I flip it over here and write all these terms on the other side, everything becomes negative. And so does it open up or down? That's a very good question, right? If I wrote all these terms on the other side, I would have negative 6x squared over here plus 11x plus 35. So, you know what I mean? Which, does it open up or down? So that's a bit of a question. So this is a good strategy. Find the zeros. It doesn't matter if it opens up or down. The zeros will be the same. You see that? And then you can quickly do a test point to find out the area if it works or not. So where is 0? Where's 0? Is it in this middle section?
Yeah.
Yeah, because this is negative and this is positive. So 0's in here somewhere. So I'm going to check x equals 0 as a test point, because I know it's in here somewhere. And I'm going to see if that makes this original. Let's go with the original inequality. Let's see if that makes it true. And I go with the original because this is the one. I haven't moved anything around yet. I haven't touched anything. This is, if I've made an error here and I check down here somewhere, I could lead myself to a false answer. So I'm going to check the original because I haven't touched the original. So just try that. So if we go 0 is greater than 0 plus 35. That 0 is greater than 35. Is that true?
No.
That's not true. So it looks like this inequality is not true in the middle here, but is true on the outsides. And I'm going to do just a quick check to make sure of a number that's out here. So this is 3.5, so I'm going to check 4. Okay? I'm going to check the number 4 for a possible answer here. So 6 times 4 squared is greater than 11 times 4 plus 35. So 4 squared is 16, times 6 is 96, I think. 96, 44 and 35 is 79. Does that look true?
Yep.
That does look true. So it looks like, and guess this, look at this. If this was negative 4 inside here,
That would still be
and this was negative 4, this would still be 96, but this would maybe be a negative number. So it's still going to be larger, so yeah, it's going to be good over here too. So you could check both sides, but you don't even really have to. So the solution is going to be, solution set, is all x values that are less than, now is it or equal to? Nope, not or equal to. So I'm going to go x less than negative 5/3, comma, as well as x greater than 7/2. Okay, now you could graph that and actually see what's going on there. Graph it. Yeah, you could graph this one, this second line here, this as a function, and see if it's greater than 0 in these areas. But is that what the back of the book says? Hopefully. Anybody check? Yes? Good. So that's that number. Does that answer the question there? Yeah, you're good? Good. Anybody else have any questions about this one before I close it down?